あ、仕事の連絡が来た、こんな時に。
わかる。私はもう仕事のチャットを。OK。わかる。私はもう仕事のチャットを。OK。Okay, live start. Shin, please chat.
今、もう何人見に来てるかってどっかで見えます？そっちですかね。
はい、今、同時配信数17、20人今、接続が来てます。
20 people are already watching this.
Okay.
This chat.
I see. It's live. Yeah.
Yeah, today maybe 100 people watching this event. Maybe. 誰かのがビデオループしてますよ、音が。
ごめんなさい、自分かもしれないです。
はーい。ちょっと私はまだ設定をいろいろいじるので、しばしご勘弁ください。7時になったらイベントスタートします。
あれ？あ、来た来た。
オーライブしときながら誰も喋らないっていう、ね。頼むよ。ちょっと、これ喋りながらだと私マジで設定が始まるまでに間に合わないんで、お願いしてもいいですか？
なるほどね。もう見に来てる人がいるのかな。コメント欄は何も動きがないので、まだ待機。
はないですが、でも30人ぐらい今もう見てるはず。
なってますね。
今日のセッションは Java のマイグレーションとかJava とかフレームワークのバージョンアップとか、あるいはリファクタリング、テストコードだったりするリファクタリング、あとは設定ファイルのマイグレーションも含めて、なんかそういうものに使えるツールを今日は紹介してもらいます。内容はね、すごい面白そうですけど、やっぱり英語っていう障壁で、若干いつもよりは人数が少ない気もしますが、まあ皆さんのならいけるよ。大丈夫だよ。まあね、デモと資料もあるのでね、それを見ながら、デモあるのかな。Jonathan, will your session include some demonstrations?
Yes, we're going to demo running recipes. We're also going to write a new one tonight to just a simple one that will help remove a use of Google's Guava and just use the Java standard library instead.
Oh, really?
So the goal of these recipes in general would be to not use third-party dependencies when you don't need to anymore, which of course simplifies the application and
I see.
reduces the problems that can be caused by introducing those. Yeah. So we'll do that live. Hopefully everything works. Developing that recipe, and then we'll test it on about 50 million lines of Java code towards the end of the session.
I see. Thanks. 今日のセッションはデモもきちんとありまして、本当だ、トップチャット見てた。Google Guava のものを Java 8のストリーム API に置き換えるとか、そんなこともやってくれるようなので、楽しみにしてください。 確かに上位チャットだけ今まで見てましたね。上位チャットとライブチャットって違う。でも今のところ上位トップチャットとライブチャットって同じものが見えてるので、
うん。
大丈夫かな？うん。
これ、ちなみに、このツールでですね、ツイッターのコメントをここに表示させることができるっぽいですね。
ここにって、
あ、
どこに
出てきた。
ほら。
ツイッターじゃん、YouTube のコメントね。
そう、YouTube のコメント。
なるほど。
なんか質問があったらここで表示すればいいんだね。
これ誰ですか？この写真誰ですか？写真ですか？
私はちょっと全然知らない人だと思うんですけど。いいですね。これ、今日実は初めて使うツールを使っていてですね、ストリームヤードという新しいツールで配信を試みています。ずっと最近、Zoom でやってたんですけれども、ちょっと違うのにしてみようかな、みたいな感じで、お試し利用でございます。なんか事故ったらごめんなさい。多分事故ったら全部私のせいです。
はい。全部何が起きても、セッションが途中ではい。
やめて。
全部前さんのせいです。
おすすめされたんですよ。他の配信をいっぱいやってるようなお友達に。何がおすすめですかって聞いたら、人数少ないならストリームヤードがいいですよ。この下の文字入れとかも結構簡単に作れるんで、割と気に入ってます、今のところ。
質問多分作るので、まやさんが英訳してくださいね。
マジでちょっとね、私それをやってる余裕があるかわからんぐらいこのツールで今あたふたしているよ。
外資系エンジニア？
いや、外資系プリセールス
外資系プリセールスがね、英語できないわけないですからね。
いや、私めっちゃ日本リージョンの人なんで、英語使う予定本当にゼロですよ。
So, yeah, we will start in a few minutes.
Sure.
それ。今日は皆さんどういう内容を期待して見に来てるのか、これナイトセミナーだからとりあえず来てみたのか、このツールをね、僕はこのツールどう使えるのかなと思って、すごい楽しみに聞きに来てるんですけど、皆さんどの辺聞きたいのかなみたいなのありますかね？ありますかねって言われてもセッションに反映できるかっていうと、また別の話。
質問には反映できるんじゃないですか。
そうですね。岡崎さんも来た。さあ、あと1分弱ですね。時間になったら、今日はじゃあ帝国から始めますね。今日は、前回30分。
前回ね、30分遅刻だったんでね。
若干遅れたんでね。
ちゃんと英語で書いてくださってる方がいらっしゃいます。
時間になりましたね。じゃあ始めましょうか。JJUGナイトセミナー2021年7月度のJJUGナイトセミナー始めたいと思います。今日は、元ピボタルかなのジョナサンさんに、OpenRewriteっていうプロダクトについて話してもらいたいと思います。Java とかフレームワークの、アップグレード、あるいはマイグレーション、でそれに伴うリファクタリングとかも含めて、いろいろ自動的にコードとか設定ファイルとか直してくれるツールだそうです。ちょっと私もそのツール自体、概要しか把握してないので、どんなツールなのかすごい楽しみにしてるんですが、はい、皆さんも楽しんで聞いてもらえればと思います。So, okay, Jonathan, can you please start your session?
Sure. Thank you for having me. I heard you had a good introduction there. Well, tonight we'll be talking about OpenRewrite, which is a open source automatic refactoring tool, especially for Java code, that helps you perform things like framework migrations or other sorts of code cleanup tasks in Java. And to introduce it, I will share a little example from the original use case for it back at Netflix when I worked for the engineering tools team in 2016. And for that, I'll show here my screen for a moment, and we'll get going. So Netflix had an internal logging library that they had written in the early 2000s. And at some point, they wanted to just use the regular SLF4J library, but they deprecated the internal framework that they had called Blitz4J and tried to encourage everyone to move. But there was lots of code written using the old logging framework. And 6 years after deprecating it, there was still several million references to the old logging library. So the old logging library looked something very similar to what we do with SLF4J. It looked something like this. You had a logging statement up top or a logger field. And when you use the logger, there would be an argument like this where it's a streaming %s. This is kind of like the string.format way of parameterizing a string. And then the error or the exception would occur second in the argument list. And then lastly, the parameter that you're substituting would appear. And so they were trying to change this into something that looked like this, where it's a slightly different type up here, where you use the brackets, where the parameter appears second and the exception appears third. So see, the exception was second. Now it's been moved to this last position here. So if you try to do something like this with a regular expression, it's very difficult because, of course, this logging statement spans multiple lines. It could have comments anywhere. This could be a string concatenation or a method call or anything. So it's very difficult to do this kind of thing with a regular expression. And so really the solution involves performing abstract syntax tree manipulation. So the compiler, when it operates on source code, it of course turns that code into a tree, and it adds type information to that tree and then generates bytecode from it. If you want to perform these sort of operations, you're left trying to take the tree representation of this code and changing the tree in one form or another, and then printing the tree back out to source code in order to make that change. But the typical problem with these tools that build tree manipulations is that compiler abstract syntax tree and many abstract syntax trees don't preserve the formatting of the original code. And so if, see how we've got this continuation indent of 8 spaces here, maybe it was even incorrectly formatted and only had 2 spaces of indentation here. A developer that saw a change from this into this would expect that the original style of the code would be preserved and not changed. But that was not a feature of many abstract syntax trees that we found to exist at the time. Also, some abstract syntax trees that you would build on, like a Java parser or some of the other trees that you find out there, lack type information. So it would lack an understanding that this logging statement or this logging statement here referred to the Netflix internal Blitz4j library as opposed to some other logger like a log4j logger or something like that. So that was what we originally did. After building this refactoring automation, we were able to do away with this API. Again, after it had been deprecated for 6 years, we were able to do away with this API in a couple weeks and not use it anymore. From there, we've started to expand on the capabilities of this core refactoring engine, and this has been completely open sourced under a project called Rewrite, or under the GitHub org OpenRewrite. This contains all the base refactoring operations and so forth that we're going to show tonight. So since the original day where we started this at Netflix, we've expanded the capability of the base refactoring engine to be able to do things like migrate from Java 8 to 11, migrate from Spring Boot 1 to 2, migrate from JUnit 4 to 5, assert JUnit asserts to assert J, log4j to slip4j. So a lot of the big tedious refactoring operations or migrations that we have to do by hand can be done automatically now. Let's look at this project and all of these, Rewrite contains things called recipes, and recipes are an encapsulation of the steps necessary to do a migration. All of these recipes are open sourced in one of the modules underneath OpenRewrite. So there's recipes to help you manage your Spring code, to manage unit testing code, to migrate Java versions, to manage logging framework usage, Micronaut, Quarkus, etc. So there's quite a bit out there already and more coming all the time. Let's see, and then what we also have been working on is a service that we're increasingly making available to the public that can execute these recipes on a large amount of code. And that's what I'm going to show next. We have a service called Moderne, and if you at any time you'd like access to this, you can go to moderne.io and sign up here, and we'll send you access to it when we can schedule a time. All of these are the recipes that the OpenRewrite recipes that we can use here. So something like migrate Java 8 to 11, like I said, or JUnit asserts to assert J. And let's just see some of this in operation. So I'm going to look through the catalog here and look into Java recipes and Spring, and maybe go into just these core recipes here. And we're going to look at removing the old request mapping annotation, which is no longer necessary in many cases. The Spring team recommends using the more specific get mapping or post mapping. And if you don't, in fact, if you continue to use request mapping and don't constrain the HTTP method, this actually represents a CSRF vulnerability in the code. So it's definitely best to use the specific mapping when possible. So let's just look at Spring Cloud itself, which has a lot of repositories. We're going to look at 22 repositories here and just run this particular recipe on Spring Cloud. So the service has the abstract syntax tree representation of all these Spring Cloud repositories cached and is able to execute these recipes across all of those repositories. So here we see we can filter this down to just the things that have results. And so you can see that many of the Spring Cloud repositories themselves haven't yet been able to modernize to use the specific HTTP verb. Let's look at, say, Spring Cloud Gateway here. And we can look at the diff and see that here we've stopped using this request mapping annotation and instead turned it into a get mapping. Same here. Notice that the import is removed and a new import is added here in the correct place. It's kind of orders the import correctly based on what the style that it can discover early on. And if we just kind of see if there's any other variations on this. Here you can see where this was a request mapping that had a method equals patch. And so we're able to detect this and turn it into a patch mapping. And also, because, at this point we've removed the method, we no longer need to specify this attribute name here because it's the default. So we're able to simplify this whole expression down to just patch mapping. But in this case, because we still have a content type produces, we're able to change the annotation but leave the other argument. Similarly here, this argument even appears on the next line, and so forth. So we can take this diff that we see here and actually just create a pull request from it, and we'll go ahead and do this. I'm going to say we're going to just polish the request mapping annotation, and this is just going to create a fork of this repository for me. And push the change that you see here as a commit to that repository. And then we can just go to GitHub and see all the same changes that we just made there. And so I'll create a pull request here for one of the Spring Cloud team members to look at the use of is the more specific HTTP verb. And so when one of the Spring Cloud team members is able to see this will pass their CI checks, and they'll be able to modernize their use of this particular annotation. So we could go through and do that for each of these. The Spring Cloud data flow has 30 files or so that you touch. So it's much quicker if you want to make these kinds of changes to do so with these recipes than it is to go by hand and do this. Overall, this is 95 files that you need to change in this set of Spring Cloud repositories. So let's try to do something a little bit different. That looked not so complicated. We'll do like a parameterize, or maybe browse to this one. There's a lot of recipes around log statement manipulation. If we look at SLF4J, there's this idea of parameterizing SLF4J logging statements. And maybe it's easier just to run this so you can see what this would do. Let's see what some of these look like. Maybe look at the Spring Cloud AWS one. So this is the situation where looks like that one's okay. This where you would have a string concatenation in the logging statement, but it would be more performant actually to use the parameterization syntax, because the concatenation is only done if the logging statement actually winds up writing to a logging appender. So this is something we all know, but and probably most of the uses of the logging library in Spring Cloud AWS use this parameter, but here it doesn't. So it's a quick way of going and finding those and correcting them. So that's sort of another example of it. Maybe we'll do something a bit more complicated, like migrating to Spring Boot 2. And I'll look for this old pet clinic repository that that Josh Long likes to use and run this one. And so in addition to being able to make changes to Java files, this is also able to, there's a Maven abstract syntax tree built on top of an XML AST, and we're able to make changes in the POM itself. So updating this version, we don't need this time leaf property anymore. You do need to use Spring Boot starter validation now if you use certain kinds of code. WebJars is not necessary anymore. And then the code is changed in a similar way here. Some of the changes can be complicated, like conditional on being changes into conditional, and then you need to generate this any nested condition implementation. And part of the goal here of OpenRewrite is when we generate code like this, or when we change code, that the white space style here is respects the style of so if this is 4-space indentation, this is going to have 4-space indentation here. If this project happened to use tabs, we would generate code that had tabs. We would look at the import layout of the project and respect the import layout style of the original project as well. So all these are sort of goals to work on.
Mr. Jonathan,
Yes.
Can you please make a font a little larger?
Oh, sure. Yeah. So yeah, you can see here the original style of the code is preserved here as we generate these changes. So here you don't need auto-wired anymore. You can take this attribute here, owner ID, and if it matches the parameter name, hide this white space. If owner ID matches the parameter name, then you don't need to have this specified anymore. So we can drop that. They want you to use JavaX validation now instead of the Hibernate validator. This same thing that we saw earlier, request mapping and get mapping. So a lot of different changes go into what it means to move from Spring Boot 1 to Spring Boot 2. So let's maybe look at what defining one of these recipes looks like. And in many cases, when it's something like this, where we're just moving from Hibernate validator to JavaX validation, we can define this in a relatively simple way, in even a YAML file, because it's we can build on base recipes that are provided in OpenRewrite. So this is an example from rewrite testing frameworks of the part of what it means to move from JUnit 4 to 5. And here you just see a recipe defined in each YAML block here. And let's look for one that's relatively straightforward. Like there's a recipe called change type, and we just say what the old type was and the new type was. And this will go and look for any references to assume and turn it into a reference to assumptions, making any changes to the imports as necessary, and changing the reference as it sees it throughout the code as well. Sometimes you could do something like reorder method arguments like this. String and Boolean have been inverted, so the Boolean comes first and the string second. And so we're able to do that. We can look to exclude dependencies where they are coming in transitively. We can add dependencies, but only if we see a particular use of JUnit 5 somewhere in the project. And so you see here the idea of going from a JUnit assert that to a matcher assert in a particular way. So, these recipes can be assembled out of these building blocks to build higher and higher order functionality. If we look at this recipe that we ran, the Spring Boot 2 one, it's one operation moving from Spring Boot 1 to 2, but what it involves is a bunch of recipes that perform individual pieces of this migration, like upgrading this dependency, changing this type, and sometimes recipes can depend on other recipes that themselves have pieces to them. So Spring Boot 2 best practices involves these three things as well. So recipes are like a tree of operations that lead to higher or more and more complex behavior. So sometimes, like, you can define the recipe declaratively like this and just ship it as a YAML file along with any jar. And you can apply that via one of the Maven or Gradle plugins here to any repository that you have. So what that looks like in Maven is you would apply this plugin, or Gradle, you would apply the rewrite plugin. And then configure one of these recipes that you can find in the reference material here. Here's a listing of all the recipes that are available to use. And once it's configured, you can run a build tool task locally, like rewrite run, or for Gradle, it's called rewrite run without the colon. And it would apply all those changes on disk locally, and you could review them and commit them. So using the Maven or Gradle plugin is equivalent to what we did to Spring Cloud Gateway earlier. It's just, instead of issuing a PR, you just have the changes applied on disk for you to see there. So sometimes recipes involve more complicated things. They're not. And rewrite recipes can be written in Java itself to perform more complex operations. And we're going to go through an example of that and actually write a recipe that migrates you from the Guava, the Google Guava Maps class. This Google Common Collect Maps contains some methods called like new linked hash map. And here in the doc, you see note for Java 7 and later, this method is now unnecessary and should be treated as deprecated, because you should just use the Java standard library directly. So for some projects, they may use Google Guava just for this particular method, or for some methods like it. And if you could just use the Java standard library instead, you could remove the dependency on Guava. And of course, that would make the project have a better dependency hygiene and be less subject to breakage if this method were removed in future versions. So let's write a recipe to do this migration away from it. So, and we've got similar recipes, but we'll just write another one here to do this. I'll delete these here, and we'll get going. So let's write the test first, actually, so we can maybe understand what it is that we're trying to do. And we'll say no Guava maps new linked hash map test. And so we're going to, right now we're writing these tests actually in Kotlin, just because it had good multi-line string support, but also supported older language versions. So that's the reason we've done that. But replace Guava maps new linked hash map. And there's a method on this recipe test called assert changed. We're going to say that we can specify what the code should look like before and after. And we're just going to specify this code in strings here. I'm going to create over here in the main source set the actual recipe class so we can refer to it here. And this is going to just extend recipe. And we have to provide a display name. We'll say use new linked hash map instead of guava. And we can provide description text here. It says use the Java standard library where possible. And we'll leave this for now, but so over here in the test, we'll say that the recipe that we want to use, that we're trying to test, is called no guava maps new linked hash map. And then in the before text here, we'll say we're going to provide some sample code. And so we're looking at some class, and maybe it has a map of some map here, and we're using maps dot new linked hash map. One of the cool things here is that the OpenRewrite test unit test harness. Notice how the IDE is actually syntax highlighting all the information between these strings. JetBrains has an annotation called @language that if you add this annotation on any string, then it treats any method invocations of this. It treats the contents of that string as if it were Java code. So it's kind of neat because you can, the IDE, as you can see, would help me write the Java code inside of this string that I'm using for this unit test. And so this is the before, and then after what I want to see, and actually I'm missing an import, one more import here. Import map as well. And after, let's copy this, but what I want to see is just new linked hash map instead. Again, see it tried to add this import. It's not, it doesn't do the same kinds of things it does with the regular IDE, but it does help out still writing these tests quite a bit. And so this is, we're going from this to this. And that's what we're gonna try to do. So over here in the recipe itself, we could define a new visitor. And so OpenRewrite uses the visitor pattern. And what the visitor pattern does is it navigates this tree, and allows you to hook into various parts of the tree to perform some change. In this case, the change that we're trying to make is to a method call called new linked hash map, and we're trying to change it into something else. So here in this visitor, we can specify a new Java visitor. Let's say, and I can even narrow this a bit. And I'm basically able to specify the visit method, just intercept method invocations, and otherwise allow the framework to navigate the rest of the tree for me. So I don't need to worry about anything else. So I'm looking for a method invocation. And so I really need some test that says if, this is a linked hash map call, or a Guava linked hash map call. So how do we do that? So Rewrite has a construct called method matcher. And we could use that here to search for a particular method. So the method here is called common.collect.maps. This is the Guava type. And the method name is new linked hash map. And the form that we're operating on here has no parameters. So here we can say if new linked hash map.matches method, I want to make a change. And so how would we make this change? We're trying to change a method invocation into something that's very different. We're changing it into a constructor call realistically. So there is another mechanism called Java template that allows us to write the Java code that we want to see. Let's maybe call this, let's just move this up, in fact. Comment this out for a moment. This can even be like this. And we'll say new Java template, or rather, and we're going to build a new a Java template here. So we'll say this, get cursor, and the code that we want to see. So we just want to write code that looks like this. And I don't know what the abstract syntax tree of this new statement is with this parameter and these sort of things. So we just specify what we want to see. And then here, we'll say that we're changing this method into this template instead. And we're saying that we want to, the thing that we want to target is replacing the whole method with this. And there's no other change to be made there. So I also, at the, I have to tell rewrite what this means, because this doesn't even occur in the original code. So I'm going to tell it that as it compiles this template and turns it into a tree to insert here, that we need to, that this really refers to Java util linked hash map. And so maybe let's start with there. So we'll return this. And if we're not inside a new linked hash map call, then we just want to continue navigating the tree to go further and further down the tree and see if we find some other reference to that method that we're looking for. So we're starting here. Let's maybe run this test, and there's one more thing to do here, which is that this test is going to use a Java compiler, and we need to instruct a compiler to add a Guava to its class path. And so we can do something like this, and we have a shortcut called just class path, and you can just match for any library that's on the runtime class path of the test, and instruct the parser to use that element. So we've added Guava here to the test implementation class path of this project, so that it's available to this class path scanner to find for use in a test. So let's start here. So the test didn't work, and let's look at the diff. It looks like, the good news is it looks like we did change the method call into a new linked hash map using a template. but we still have the original Guava import, and we don't have the import for linked hash map yet. So I think there's a little bit more to do. We can come over here and say, you know, maybe remove this import. And the type again was this common Google or Google common collect maps. So let's maybe remove this one. And when we say maybe here, what we're really meaning is it may be that there is another use of the maps class that's unrelated to new linked hash map. And so just always striking this would potentially break another piece of the code. So this this recipe, this basically sub recipe, is going to check whether after our operation is complete, there's any other uses of maps. And if there isn't, it will remove it. And similarly, we're going to add an import on Java util linked hash map. And let's run this one more time. And so now that passes the test. We've changed the original method call into something that looks fairly different. It's a new constructor call now, and we've changed the imports around as well. What if there was another thing like something like this and something like this, and what's the IntelliJ default? I think it's that if there's 3 or more imports in a package, that it should turn it into a star. Let's try that and see actually what happens. What if there was like a list reference here as well? So, you know, a simple way of thinking about it would be that it would just insert the new import in the correct alphabetical order. Let's run this and see. And, you know, looks like a bit surprising. It's replaced the, I think in general, I don't remember what the style is, but the expectation would be that if you had enough imports here, that the refactoring operation, when it goes to manipulate imports, it would actually see that, okay, I'm adding one more import to this package, and so now I should just starfold it, you know, and that should be the outcome of doing the refactoring operation. So so I took this recipe that we wrote here and just published it right before the meetup talk. I built it on Maven Central and went over here to the app, and we have these, the app basically loads recipe artifacts from Maven Central, and this is the jar that we're working with, and I loaded it about an hour ago with this recipe. And so let's just try to go look for that recipe now in the catalog. It's under this Guava package here, and it's this use new linked hash map instead of Guava. And we'll just run this on everything. This is about 50 million lines of Java code, of open source code that has been pre-ingested here into the service. And you can see it's making some changes already, like to Apache Spark. Looks like, you know, we're able to change this method call here. And, you know, there was already a import on linked hash map, so all we needed to do here was just remove this import. You know, similarly here, looks like for Druid there's more changes. Again, nothing too surprising, but so that's kind of I hope a good overview of what's possible. I'm gonna open it up for questions here in a moment, but yeah, we'd love if this is of any interest to you, for you to come to this repository here and just, you know, open an issue on the kinds of change that you would like to see. If there's something you can think of that we didn't do today, then we're happy to do that. We're just going to keep adding more and more recipes to try to help make these kinds of changes. So I'll stop sharing for a little bit and look over at the comments and see if we can have more discussion from what you're interested in. So I'll wait a moment here for, yeah, thank you.
So, okay, thank you for your presentation. So, we have a lot of questions.
Great.
So, first question is here. You show?
Yes, yeah. So this is a great question about quality assurance. The recipe could absolutely contain bugs. This is why when we did the Spring Cloud PR earlier, that we have the workflows that we do. We make the change, you know, you look at the change very carefully, you review it, and you know, it's just like any other PR review or any other code review. So the way we think of this is like, you know, you want to make this change anyway. You're either going to do it by hand or you're going to have something generating the change for you. Either way, you're going to want to carefully review the code for impact on the application. But also, like any other code, when we take a recipe and we run it on 50 million lines of code or 100 million lines of code, we gain more and more confidence about it as we apply it and as PRs are issued and accepted that recipe does what it's supposed to do. So we start out writing unit tests just like we did there in the demonstration, but like anything, unit tests don't cover every case. So you wind up writing more and more tests as you see more real world use cases. Yeah.
Okay, thanks.
Thank you.
And next is here.
Yeah, so is it a tool that works in an offline environment? And the answer is yes. I think I showed that a bit late in the demo, but if you go to docs.openrewrite.org, there's a guide on how to use the Maven or Gradle plugins to apply any of these recipes on a repository that you have locally. And so you can take a JUnit 4 to 5 or assert to assert J or any of those things and sort of do them locally. That's actually something we didn't share earlier. Let's do one of those more complicated things like assert to assert J. Let's look at, say, like assert J. I think Phil Webb on the Spring team spent a while, I think, looking at this. Maybe I think Dataflow doesn't entirely use assert J. The Spring team has been trying to move to assert J for a while. But it's just really, you have to go to every assert statement and make that change. And there's a lot of, it's a lot of assert statements in a code base like this. So we'll run this one. Hopefully they still have some. So there's some dependency changes, but then, yeah, also, yeah, you see this assert true. The original JUnit assertion gets turned into assert that is true. You see, we take these original, this one could be relatively complicated. You have this whole string and this chain of method calls, and you take this whole parameter here and move it to the first parameter, and the first parameter gets moved to the second position over here. This is a good example, I think, of why abstract syntax tree manipulation is really the way to go about this. This would be really hard to do with a regular expression-based engine, for sure. Yeah.
Yes, thank you.
Thanks.
Next, please. Here.
Yeah, so it's I'll show this one more time here for the main docs page here is at docs.openrewrite.org. It contains guides for a lot of the big refactoring operations here. There's a recipe reference that contains a catalog of all the available recipes. And this is just auto-generated off of the actual, off of the recipe code itself. So as we add additional recipes, you can generate more docs. If you were to ever write recipes internally, we do have a tool that can generate markdown docs with this information, so that you see example usage and so forth, and you can distribute that markdown inside your organization to make it easier for your developers to consume. There's also a reference to this docs link here on the main repository, if you should lose that. Thank you for that question.
The next one, please.
Yep.
How does
So it says, how long does it take to finish migrating a typical, say, 1,000 class large project? That's the recipe itself can run pretty quickly. When we did that Guava change earlier, we were running on about 50 million lines of code. I think I can share the actual repositories that we have ingested so far. I'll hide some of these things like version created by, and you can see that some of these projects, like especially the Apache projects, contain roughly 11,000 source files and 1 to 2 million lines of code. So some of these projects that we were operating on were fairly large.
Yes, please next. Yeah.
In typical collaboration, how much manual modification necessary?
Yeah, it's I could understand that you would expect that some modification is done automatically and some is required to do by hand. There's always going to be some level of or some change that's difficult to automate, and that's okay. But it's surprising as we build on these base recipes how much of the migration we can complete. Some things that would have seemed very difficult to me a year ago around the Spring Boot 1 to 2 migration are now very possible to do automatically. One thing we didn't share is that, and I'll share this as a reminder, we actually started with the transformation case. Really, the tool is all about refactoring, but we do have search recipes as well, and search recipes just mark the original code in some way. So let's see an example of this. Like we were making that guava change earlier. So if we looked for the same thing, but we didn't have a recipe yet, we could say com Google common collect maps, I think it was, and it was new linked hash map. Or maybe just let's look for all methods from maps, because I don't even know what's being used. And I'll say any number of arguments in any method in com Google common collect maps. And let's select all the repos again. So we run this. And so we're just going to see the entire, every use of Guava maps across any project. And, you know, here there's another form actually where you see maps.new concurrent map. And so what's interesting here is that when for this search, we had a recipe that added what we called a marker to that tree. And so a marker is something that doesn't exist in the Java language. It's just like, it's like an annotation, almost like just a note that we're putting on the tree. And then we can render that note or that marker in different ways. And in this case, on the service, we've decided to render that marker as a comment that just points at the element that we've found. And because we've generated a comment, when we go to print the tree, we can still do this regular git diff, and it really highlights the searched element, just like if we had actually made a change. So I could put in this comment like a to do or a fix me or something else that pointed a developer to a piece of code that they needed to modify by hand. And even that will make it easier for you to go identify the places where you need to make a change.
Cool.
Yeah.
Yeah. Thank you.
So interestingly, we see search as a special case of transformation rather than the thing to start with.
Yeah. Yeah, I understand.
Okay, next.
My question.
Yeah, is to provide an IntelliJ plugin. I think it would be nice to have an IntelliJ plugin. Yes. For now, of course, you could, if you had a Maven or Gradle project, just click on the Gradle task, rewrite run, and run it there on the project, and that would work. But yeah, I'd be interested in seeing something like this too.
Yeah. Yes, please.
Yes, please. Yeah.
Okay. Go ahead, the next one.
Sure.
Yep.
Can we?
Yeah. Yeah, JSP files. This could be done. Interestingly, the Java compiler has a like a internal part of the compiler is a JSP compiler. It's not something we support today. I've looked at it a bit in the past, but that's if you have a lot of that code, you know, file an issue, and it's something we can look at again. Since JSP is such a hybrid of XML and Java, it's it shouldn't be too bad to do. It's a good reminder. It's been a couple years since I looked at that one. Yeah.
Yeah, but I think it's a little hard to parse the JSP files.
It's so interestingly, we you know, when we build our AST, that's a hard thing to do, to add type information to the tree all the way down. And so OpenRewrite doesn't do that work. It actually takes the OpenJDK compiler through its parsing and tokenization and type attribution of the internal compiler AST, and then we pause the compiler and we take that internal compiler abstract syntax tree and map it to a rewrite one. And part of that mapping is to go look for all the white space and add that to the tree. And we cut cycles and compact it and make it because the compiler is using that AST for a different purpose. It's using it to generate bytecode. We're using it to perform transformation. So there's different characteristics we need in our tree. But at any rate, the OpenJDK also contains a JSP compiler and has a JSP AST. And so we would do the same thing there, is we would just allow the compiler to do all the hard work of understanding how to parse a JSP, and then we would just map it to an internal AST of ours to operate on.
Yeah, I see.
Yeah.
Okay, maybe next one is Rust. Last question.
Yeah, so the question is who recipes are made by, and our team does make a lot of recipes, but we want to see more contribution of these from others as well. The Spring team has 2 full-time engineers working on developing recipes to migrate you from legacy Java EE applications to Spring. Red Hat has a couple engineers looking at developing recipes to help you migrate from legacy Java EE apps to Quarkus. And we would, the thing that I shared earlier, which was this, I'll show you the path and really point out the path here of this YAML file in rewrite testing frameworks, where we showed this change type, assumed assumptions, and so forth. And this is just a YAML file. It's just a file in metainf/rewrite and any file named .yaml at the end. So what I would love to see in the end is that when the Spring team releases Spring Boot 3, that Spring Boot 3 is shipped with the recipes that move you from Spring Boot 2 in that library. So when you pick up that new library version, you also get the recipe that migrates you from the prior version of the framework. That's something I would love to see more generally, is that these open source framework authors develop the recipe that helps you migrate when they make breaking changes, that helps you migrate to the new thing.
Okay, thanks.
Good question.
And more questions we have. Wow.
Can this tool parse Java Lambda expressions? Absolutely. I think I can show that. Whoops. Got to get back to the sharing window here. Yeah, so here we actually have a set of unit tests here in the core project for this, and this took a while to write, but every Java language construct that exists, including Lambda. So we proved ourselves constantly that we're able to parse untyped Lambdas, ones with parentheses, spaces in the middle, all these weird variations on things that you can see in code, to be sure that we not only can parse it, but that that we don't lose anything. Like I don't lose the space in the middle, so that if we parse it in a certain way and emit it back out, that it looks the same. That's always a big goal. Every once in a while, we'll see something new in the language that I've never seen before. And I'm always surprised by things. I remember running these tests at Netflix once, and I saw somebody had put an annotation on a typecast. I didn't know you could do that. It's something that looks like maybe like just go into some class so we can do one. You could have like you could have a typecast here and say, you know, non-null string, you know, like some weird thing like this. Like this is actually a valid Java, you know, a place you can put an annotation. You can technically put annotations here or here. I think there's like things you don't normally see in Java code, and but we run on, you know, many millions of lines of code, and if you run on enough code, you're going to see weird things that you didn't know were possible. Yeah.
Okay, next.
Okay.
I love this question on language migration. You know, I really have an interest in writing the COBOL AST not too far from now. I used to work for an insurance company that used quite a bit of COBOL. And I'd be interested, what language, do you know what, is it COBOL 85 or COBOL 2004, or which variant of COBOL do you see in use right now?
And not so many companies in Japan.
Lots of different ones. Yeah. The easiest language migration I can see happening in the next couple of months would be Terraform JSON to the HashiCorp configuration language. That's a fairly easy thing to do. We do have it's outside of the Java world here a bit, but we do have things like best practices for AWS. And so keep sort of expanding here. You can see where it's, you know, able to make changes to Terraform files to add, you know, more secure configuration and things of that sort. So that's something I can imagine. But of course, Java to Kotlin is a much more complicated operation.
I see. Thanks.
Yeah.
Okay, next, please.
Next one.
Yeah. So why is it so fast? I think if we do some, I mentioned that the compiler has an abstract syntax tree it uses to generate bytecode, and we have an AST we use for a different purpose. And so we have some special characteristics to this AST. One is that there's it preserves formatting on the AST, but another one is that we optimize it for serialization so that we can operate on it offline. So you could take a rewrite AST and use a regular Jackson mapper and actually write it to disk and then suck that in later into memory and operate on it. So on this service, we have about 8 virtual machines running right now that have this, 50 million lines of code roughly deserialized into memory, and then we can just operate on those things. We have some other ways, other tricks. There's something called an applicability test. So if you look at, say, change type, which where you're just changing from one type to another, like this example of going from org JUnit assume to org JUnit Jupyter API assumptions. The recipe, the rewrite recipe, has a test called a single source applicable test. And what that does is allows us, we say that we only really want to run this if we can prove that the file uses the old type. So it allows us to basically shed work early on when we know that there's not going to be any further change to this file. And so things like that. We also have whole source applicable tests that will say, like, if you don't have a dependency on Guava, then you're never going to find a Guava type anywhere in this project. So don't bother looking. And so there's just different levels of optimization there.
I see. Thanks. The next one.
Yep.
Yes, any significant feature we want to add. We want to add everything, of course, but one thing I've been working on the past couple days is adding a Groovy AST, actually. And so that you can do, I had a tool I wrote at Netflix years ago called Gradle Lint plugin that would actually do these kinds of refactoring operations to Gradle files to update dependencies and plugins and so forth. And it was also an abstract syntax tree manipulation, but it was based on Groovy's dynamically typed language. It doesn't have types a lot of places. So it was sort of accurate. I'm really excited about this Groovy AST because we're able to use Cedric Champeau's work on the Groovy static compiler to actually statically type attribute a lot of Groovy code that isn't intended to be statically compiled. So I can look at a Gradle file and go through that tree and see, oh, this is really a dependency here. This is really a plugin here, and make really accurate changes. And what's really exciting about this is that the recipes that we use today, like change type and change method name, actually work on that Groovy code as well, because Groovy is just a superset of the Java language. So I'm really excited about what we've got coming for Gradle auto remediation. And then we'll also want to extend this concept to Kotlin as well. So when you do a change method name or JUnit 4 to 5, that it works for Java and Kotlin and Groovy code all together at once.
I see.
Okay, maybe Rust. Rust again.
Does it support Java 17? I actually had, there is a branch somewhere where we added Java 17 support just to prove to ourselves that the compiler hadn't changed too much. And we need to get that merged. I can mention that to Sam, one of our developers. The hardest thing about getting to Java 17 was actually the build tooling. We have in our repository all of these projects. Like we have the Java 11 AST and the Java 8 AST together in one repository. And so we'll add a Java, you'll see another one, Java 17, pop up here shortly. I think there's actually a branch, Java 17 here, that has that code. And it really the hardest part was the default GitHub Actions container is Java 11 still. So we just had to roll a custom container to be able to build it in CI. And it's basically build tooling. We'll get that worked out.
Okay, I see. Thanks.
Yeah.
Okay, so I think we finished the questions.
Okay. Yeah.
And yeah, audiences are saying thank you for your session and for the answers. Yeah, very nice.
Thank you for the invite. Really appreciate it. And
we appreciate
all the questions. Okay.
Okay, so let's finish today's nice seminar. Okay, I will speak in Japanese a little. これで今日の、JJUGナイトセミナー、ちょっと時間早めですが、終わりたいと思います。で、もともとのアナウンスで確か8月に LT 大会をやる予定で、多分話してましたよね。話してたんですけど、LT 大会は、10月、
9月ではない予定。ちょっとごめんなさい、未定になりました。ただ先送りにしてやる予定です。ライトニングトークはやります。やりますが、いつになるかちょっとずいぶん先にしますっていう。
今のところ10月予定ですね。
そうですね。
はい。じゃあ10月に、また近くなりましたら、セッション募集とか、告知とかしますので、その時にはぜひ皆さん申し込んでください。それでは、今日の JJUGナイトセミナー。
待ってください。まだね、お知らせがあるんですよ。お知らせがあります。で、ちなみにその8月はじゃあ何をやるかというと、もう日程は決まっていて、8月10日にスプリングのジョシュロンさんが、日本の、このセッションに参加してくれる予定です。時間は多分、次回ですね。もうちょうど1ヶ月後ぐらいです。で、時間はいつも8時スタートなんですけれども、今回9時スタート、次は9時スタートになる予定ですので、いつもよりちょっと遅い時間になりますので、ゆったり準備をして皆さんご参加ください。っていうのがまず一つ目で、もう一つ、つい最近終わったばっかな気がしていましたけれども、JJUGフォールの、イベントの日程が決まりましたので、皆様にお知らせです。次の JJUGホールはですね、11月の21日の日曜日の予定です。で、まもなくスポンサー募集とともに、CFP、Call for Proposal、喋りたい人の、私喋りたいですっていう投票というか、応募が始まりますので、JJUGからのアナウンスを見逃さないようにしておいてください。ツイッターとかドアキーパーとか、あと JJUGのホームページとかで流れると思いますので、皆様ぜひウォッチしておいて、何か喋りたいものがある人、もしくは初めての登壇やってみようかなと思う方は、ぜひこちら応募をお願いいたします。はい、喋り切った。
はい、ありがとうございます。はい。それじゃあね、今日のナイトセミナー終わります。Thank you, Jonathan, for your great session. 皆さん、
Thank you.
Yeah, thank you. 皆さんも、今拍手してるかな？
拍手微妙にしてる。みんな拍手して。
Yes, applauding you. Yeah. So, let's finish today's seminar. それでは終わりたいと思います。
さようなら。